Hello, welcome to this part of a tutorial. I'm sorry I've not posted for a long time. Actually, there are a couple of issues I'm facing from this end. One of them is that my laptop is bad, like very bad. I need a new one, and I'm still looking out for money to get one. Okay, the other issue is time to make these videos. I've received a couple of comments and requests to make videos and all that. One particular one I want to address in this video is the request to send data. I don't actually have time to sit down and write out those data, and the ones I used to develop the videos, I don't have access to them at the moment. So I'll advise, if you need the data I used for the simulation and the models, the videos which you actually watched, I think it's pretty good if you go through the videos and then write off the data yourself. You can copy this data. It's not actually that difficult. Just for each of the values I'm entering, you can just write it down, and that's will form the data I actually used. I'm sorry if I couldn't send the data. That's the issue. Okay, now having said that, someone made requests that I do this video, and I'm just sending it. So I received this data. I'll have to apologize, my keyboard is bad. Like I said, my system is really bad, so that's why I'm using this on-screen keyboard. Okay, so this is the data. I'll try to be doing this from now on, going forth, to be displaying the data before I start the simulation, so you can go through the data and see what we have. So we're actually doing a gravel parking, open hole completion gravel park. I've not done a video on this, so this will actually form a video on gravel park. Okay, so, and there are a couple of questions here to be answered. Okay, so let's just quickly go through the stuff, go through the data, and then we start the simulation proper. There are a couple of things I observed. One is, this is an oil well, I presume, but the overall heat transfer is actually that of a gas well. So I don't know, but I'm just going to model with whatever was sending me. So let's go. So I'll split the screen to help me. Okay. So now the first thing, like all other simulation, the first thing you have to do is your option summary. So I'll go there. Okay, so we have oil and water, and I think everything here is good except this. So I'm just going to come here and I'll change this. The well completion type is open hole, and the sand control type is gravel park. That's the only thing I'm going to change here. Then I'll continue with my model. So I'll come to this and let's apply the data. Okay, so the solution gas oil ratio is 357. And then the oil gravity is 29.5. The gas gravity is 0.65. The water salinity, do we have a value for that? Okay, 20,000. That's 200,000. We have 20,000. Okay, so I didn't receive any of this and no data for matching, so I'll just continue. Let me model the down hole, the equipment, or get all, and select the surface and then edit. So for the deviation survey, we're told that the deviation is 0, and our well depth is 9550, so we should have 0 and 0 and then 9550 and 9550. Okay, so that's that. The next thing, this is the only information I got here, since it's open hole, is that we have a tubing, and the tubing actually should be at the well depth. So I'm going to set this to 9550. Let me copy this value. So Now the tubing inside diameter, it's not actually specified, but I'm going to use from the questions. I'm going to use the first one here. That's 2 and 3/8 inches, so that's about 2.375. 2.375. Okay, so I think that's good. Now we have this, we have data for this. We have temperature at the surface to be 60, and then at the well reservoir temperature to be 95. So at the surface we have temperature to be 60, and at the well depth we have temperature to be 95, and this is 3.5. So I go done and done and done. So let's go to IPR data quickly. The question says we should use PI entry. So I'm going to use that quickly. And I'll supply the reservoir pressure, which from the question is 4135. The temperature is at 95. The water cut is at 25. Okay, so the PI for this well is actually very low, 0.22. 0.22. Okay, and then I'm going to supply the sand control. The gravel pack permeability is 60,000. 68,000. Okay, the gravel pack length, God. Okay, the gravel pack length should be 500. I'm sorry, the gravel pack length from this is 10, and the production interval is 500 feet. The well bore radius is 7, and that's 77. Okay, that's all we have, and all I have to do is to calculate my IPR, and I have an AOF of 703.1. Okay, that's good. So just go to main, and that's all. The next thing we have to do is to run this model. Let's do some sensitivity. So I'll go to calculation, VLP. Let's see. Okay, a thermal pressure of 200 is what we're given. Oh God, 200. I'll continue. First, let's check if this model is producing. Okay, oh, that's nice. So we have 115 stock ton barrel per day. That's actually low. So now the question is, what's the problem? What's the problem with the model? Let's go look at the questions. So determine the rate at which this. Okay, so it's like tubing is one of the problems, because we are asked to look at the production using different tubing sizes. And then the next thing is determine the rate that the well will flow for a top knot pressure of 300. So the top knot pressure should be another factor we should look at. So and the third question is determine optimum rate at different wellhead pressures. I think 2 and 3 should actually be the same. So top knot pressure of 200, 300, and then we'll look at maybe 400, 500, or something less. Okay, the next thing is what's the effect of high water cut? Okay, so I think water cut should be another problem. So let's go down and then look at those. The first thing is tubing. Where are you? Tubing. Okay, tubing and pipe diameter. The next thing we're going to look at is top knot pressure. Where are you? First knot pressure. Next thing we'll look at is water cuts. where are you? Oh, water cut. Is that all? I think that's all. Water cut this. Okay, so that's that. So let's look at the diameter, the ones we've been given. So the first one we actually use is 2.375. 2.375. Oh God. I'm sorry, my keyboard is just misbehaving. Okay, my mouse, sorry. The next one we have is 3.5, and then the next one is 4.09, and the last one is 4.892. Now on our first net pressure, I'll just generate this. Let's start from 100 and end at 500 should be pretty good. And with 5 values, allow it to be linear. Generate. Okay, the same thing with water cuts. So I'm going to start my water cut from 10 and get to 100. About 10. Linear spacing should be good. Okay, so I'm done, so I'll just continue. The first node is the Xmas tree and the last node is my tubing. So I continue and then I calculate. So we'll wait for this to complete and then we'll be back shortly. Thank you. Okay, welcome back. The calculation has completed. So let's look at the data. So for a top net pressure of 100, we have production for water cut up to 40%. From 50% there is no production. Okay, so let's look at a top net pipe diameter tubing of 3.5 and top net pressure of 100. We have production up to 30%. Okay, so let's we can actually view this using a graph. Let's go to system plots. Oh, that's actually very we have a whole lot of options. Data graph there. So I'm gonna look at water cut. For all water cut, let's look at water cut first, then top net pressure of 100 first, and then I'll look at this too, this tubing. So let's look at what's happening for that. So what's happening there, this is our IPR, right? Okay, but for the VLP, let's reduce some of those variables too. Let me go back and okay, I think this should be good. IPR VLP liquid rates. Okay, so you see there is production. For these labels are what I can actually get now. Okay, this is 0, 1, 0, 1 up to 0, 1, 2, 3. Then production actually ends here. That's 0, 5. So 0, 5 up to 50% water cut. There is production. So up to 40%. Beyond 40% there is no production. So that's what we have. That's for water cut. And notice that the top net pressure is 100. Let's look at top net pressure of 200. 200, we have production up to, that is for 30% water cut. Okay, 3 is, this is that. 3 is 40% water cut. Okay, it's the same thing. 0, 1, 2. Sorry, it's actually 2. production up to 2. Beyond 2 there is no production. So you can look at this graph, and I think there should be a zoom tool somewhere, or let's see, there's a zoom tool somewhere. I can't find a zoom tool. I actually want to zoom into the graph so as to see what's happening there better. So you can do this. Sorry, that's not what I want to do. Look at variables. Look at this for each of this. Let's decide to plot everything here, but the graph will actually look dirty. And that's why I was afraid. Okay, but I prefer scrolling this. So for 3.5, that's what we have. Let's look at for tubing of 4.09. We have production up to 30% water cut, or beyond 30% there is no production. So you can just go through that. So what did you actually observe? So as the tubing increases, as the tubing size increases, production reduces, right? Now what happens to the top node pressure? Let's leave the tubing at 2.35. What happens to the pressure? To the top node pressure as the top node pressure increases? So let's look at 200. What happens? We have production up to 30% water cut. At top node pressure of 300, we have production up to 20% water cut. And top node pressure of 400, we have production up to 20% water cut. Top node pressure of 500, production up to 20%. Okay, so as the top node pressure increases, production also decreases. If you look at the values, you actually see that at top node pressure of 500, we have oil rate of just 25. At top node pressure of 400, oil rate of 54. Top node pressure of 300, oil rate of 112. So as the top node pressure increases, the production decreases. So you can just go through that. And water cut, will discover high water cut leads to low production. So I think I've answered all the questions here with this. That's the power of sensitivity analysis. You can actually plot the stuff and then look at it better. So that's that for the tutorial, and I think that has actually served our purpose. If there are questions you still have, you can ask, and then we'll try to address those questions. Like I said, my laptop is very, very bad, so if you request for a video and it doesn't come immediately, please bear with me. I'm still searching for funds to get a new one. And then for those that requested for videos, I'm assuring you that once I fix my laptop and I have time, I'll do those videos and actually send. Sorry for the delay in responding to questions. Okay, for those who've just come to the channel, you're welcome. This is actually this is my channel where I provide tutorials on petroleum engineering softwares. I have a couple of the softwares which I know, which I would like to provide tutorials, but I am constrained, time and other factors. So I'll try to do my best to upload videos once in a while. But if you've not subscribed to the channel, please do also subscribe, and then like the video, and feel free to share it. It's free. I'm not charging for the videos, so feel free to share, invite your friends to watch, and then subscribe too. Thank you very much. Have a nice day. See you some other time. Bye.